Okay, so today's week 6 and we have Baconian. Just a heads up, Baconian's like kind of weird. It's not exactly like a word cipher like aristocrats were. It's not fully a math cipher like something like Visionary was. It's kind of a mix, but it's an unusual mix. So I'll get to what that means in a second. So basically it operates off of binary. So that means so we count in base 10, right? So we count like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then those were all single digits so far. And then once we get to 10, we need to put a 0 in the ones digit column and then put a 1 in the tens digit column. So that's what base 10 means. So for binary, once we get to 2, we have to do what we just did once we have to get to 10. So what that would mean is we count 0, 1, and then just how we can't put 10 in the ones digit when we're counting regularly, we can't put 2s in the ones digit when we're counting in binary. So we have to go 0, 1, and then we have to move to the tens digit column and put a 1 there. So basically, you'd count like this is your first binary number, this is your second binary number, and then you can't put a 2 anywhere because you're not allowed to put 2s in, just like you're not allowed to put 10s in. So then you would have to put a 1 in the tens digit column. It's technically the 2s digit for binary. And then you continue counting. So every time you run out of space and you think you need to put a 2, you just have to move on. So that's essentially what it is. This isn't going to be my only explanation. I get that that's kind of a foreign concept a little bit. But for Baconian, that's basically like the method you will use to figure out what letter is being communicated by like a certain series of symbols. And basically you'll have groups of 5 things. And if I just skip way far ahead to an example, I can just show you like visually what it would look like. Hold on. So here you can see that there are 2 distinct different symbols in here. There's that like weird A thing with a ring on top of it, and there's that V thing with a dot below it. But like if you look through the entire thing, you see that there's only 2 different symbols. And what we were just talking about binary is that we have to communicate with zeros and ones. So eventually, once we actually learn how to like count in binary, we're going to realize like one of these has to communicate 0. So one of these maps to 0. So just like an aristocrat, you would put like whatever it maps to underneath it or on top of it for the entire thing. Because like, for instance, I don't know if this is right, but the A maps to 0 in our hypothetical case. So you'd put like zeros underneath all the A's, and then V would have to be 1. Once again, I don't know if this is right, but that's how you would do it. Also, I don't think that's right. I think I have it backwards. All right, but before we actually like solve stuff, let's learn. So this is what I was talking about. You're operating off of 5 digit places for Codebusters, and you can never have a 2 visually. Like you are not allowed to see the number 2 in your 5 digit number. So you're starting from the bottom, which obviously in no matter what base you're in is just 0, 0, 0, 0, 0. And then from the lowest place, so the lowest place available for us to change is the ones place. That's what we'd call it since we're used to that. Yeah, it's still the ones place. So we changed that from a 0 to a 1. But we can't change that from a 1 to a 2 because we're not allowed to have 2s anywhere in here. So instead, we have to jump over to the next place available, which would be the tens place. And then we'd have to put a 1 there and switch the other one back to 0. So then the next number would look like this. The next number after that would look like this. And so on. But you can see here, you're essentially just filling up the available spaces you have with ones. And if you don't have any spaces left, then you move to the left. So here, this is like making sense out of it now. So we know that we count this way, but this is like, what does it mean? So here, this is obviously 0 because it's all zeros. And here it's 1, just like we'd count in base 10. Like this is the ones place, no matter what base you're in. And I'll get into why that is a little bit later. So this is 1. But because this is binary, aka base 2, remember that means we can't have 2s anywhere. Once we move here, that communicates 2. And so essentially, okay, if anybody can tell me in the chat or even like personal message, what relationship do you see between these 4 numbers? Yeah, let's do that. Also, don't tell me what they're being multiplied by, just tell me like what they're powers of, because that's more important. Oops. Oh, we don't know powers. Okay. That is interesting. 2 to the power. Yeah, it is powers of 2. Here, I'll make sure I teach powers then. So basically, like, yes, Sierra's right. So 1 is 2 to the 0. 2 is 2 to the 1. 4 is 2 to the second. And so on. Here, I'll do a quick helpful thing on powers. The good thing is that you don't actually have to know like how these powers work to do Baconian. So basically, 2 to the 0 means you multiply 2 by itself 0 times. So I don't know how you can like physically imagine doing that, but if you somehow can, cool. But if you multiply something by itself 0 times, just in your head, think that's 1, because you basically didn't do anything, right? So you just have 1. 2 to the first, so this thing right here, that means multiplying 2 by itself 1 time. Obviously, you can't multiply something by itself 1. Okay, wait, no, I worded that a little bit weirdly. When I say multiply 2 by itself 1 time, it does not mean 2 times 2. It means you have 1, 2, and that's it. Okay, yeah, I'm going to draw this better. So 2 to the first means you have 1, 2, and you're multiplying it by something. 2 to the second means you have 2 2s. 2 to the third means you have 3 2s. Oops. 2 to the fourth means you have 4 2s. Here, it's obviously like if you have 1, 2, and you want to multiply by something, but there's no something, then you're just left with 2. Here, 2 times 2 is 4. 2 times 2 times 2 is 8. 2 times 2 times 2 times 2 is 16. Yeah, so basically that's a quick rundown on how powers work. And that's why like every time you move 1 digit place to the left, you move up by a power of 2. So the next slide helps more with that. Yeah, so this like big thing up here, this is representing our 5-digit number. So I'll also draw it like up here. We had this 5-digit number, and this is what's represented like by each digit. What do you mean, Ethan? Oh, yeah. That's my bad. Oh, wait, no. It definitely should not go to... This is 4, this is 3, this is 2. I don't know how that ended up here. So, yeah, basically, it's just like how we count regularly, because if you think about like 701, that's just a random number I pulled out of my head. This is the ones place, 10 to the 0. This is the tens place, 10 to the 1. And then this is the hundredths place, which is 10 squared. That's how we regularly count. That's why it's called base 10. We're just essentially counting, but we're doing it in base 2. So it's a different base. So here, remember that you can only have a 0 or a 1 as a digit in one of these spots. So if you have a 0, no matter what spot it's in, that just equals 0. If you have a 1, you can pretty much think of 1 or 0 as like true or false. So like if 0's in any of these spots, it's false. Like it contributes nothing. It's just equal to 0. But say you have a 1 here and like a 1 here and 0's everywhere else. 2 to the 4th is false. 2 to the 3rd is false. 2 to the 1st is false. So you just completely ignore those. You're only looking at 2 squared and 2 to the 0, which you're considering true. Yeah, so if you have a value of 1 in that particular spot, you add up that place's value. So 2 to the 2nd is 4. 2 to the 0th is 1. 4 plus 1 is 5. So that means in binary, this number communicates 5 in base 10, because we always want to convert back to base 10 so it's easier to think about. So here I'll show the example again. Yeah, sure, go ahead. It's a little bit like off center, but basically we can see that all of this middle stuff is false. We don't care about it. We're not looking at it. We have 2 to the 0, that's true, and 2 to the 4th, that's true. So we calculate those only, and then we add them up. 2 to the 4th is 16. 2 to the 0 is 1. So we get 17. That's the process of converting from base 2 to base 10. And you guys know what happens when we're in base 10. We convert to letters. But this one, converting to letters, is slightly weird. Okay, same thing here. 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0th. False, false, false. So we're only looking at 2 to the 2nd and 2 to the 1st, which is 4 plus 2 equals 6. That's how you convert. And next slide is some practice for that. So here, just so everybody gets a chance, I guess I'll assign like 1 each, because we can go pretty slow. It doesn't matter. Actually, we definitely don't have enough for 1 each, but everybody can do 1 each, and then we can do the others together. Hold on, let me get the participant list. And by do, I just mean like you can private message me the answer that you think is right. All right, I know Ethan Lee is not here right now. Here, Aryan, you can do this one. And yeah, Ethan Lee can do this one if he gets back. Oh yeah, that is 1. I did not notice how easy that one was. Yeah, 21, nice. Wait, yeah. Yeah, 16 plus 8 is 24. Here, I'll just do this one too, since I know he's not here right now. But we have 16. Oh, you're a little confused? Which part? Which part would you like me to explain? Here, actually, maybe if you're not sure which part, I can just show one of the other ones, and it might like help your memory a little bit. So once again, I mean, you can probably do this in your head, but I'm just going to show this for visual purposes. Each spot represents a power of 2. If you have a 0 in that particular spot, it's just worth 0. I'm saying like it's false, ignore it. Technically, it's still worth something, but its value is 0, and when you add 0 to something, it absolutely like does not change the sum, right? So that's why you can just ignore all the zeros that you have in there. So the ones you are left over with, you have a 1 in the 2 to the 4th column, and you have a 1 in the 2 to the 0th column. So essentially, you basically add up the values that you have that have 1s in them. So you have 2 to the 4th plus 2 to the 0. 4, yeah, 5. So here you would get 16 plus 1 equals 7. Or did I say 7? 17. So this one would be 17. I'll just do the other ones very quickly. This spot is to the first. Yeah, 0, 0, 0. That's always the easiest. You just put 0. So this spot is to the first. So this is equal to 2. And if you add these together, you get 18. Here you just have 4 because this is the 2 to the second spot and nothing else has a 1 in it. Here everything has a 1. So you just do 16 plus 8 plus 4 plus 2 plus 1. 28, 31, I think. This is 31 minus 2, because the only thing that changes, we have a 0 in the 2 to the first spot. So 31 minus 2 equals 29. The cool thing about Baconian is that there's no modular arithmetic, so you will never actually get a result like 31 or 29. You don't have to do like the minus 26 thing to go back down to like a number that makes sense. Like, in fact, if you do get 31 or 29, you know that you assigned the wrong symbols to 1 or 0. So it's like, it's a way to check your work, basically. Because for example, if you remember like how I showed the thing in the beginning where okay, maybe I'm going a little too far, but where I said like there was this A ring thing and then the V dot thing. If there were 5 A ring things in a row, remember that we're thinking in groups of 5. That's why we've been practicing in groups of 5. If there are 5 of these in a row, then it has to be 0. And then the V dot thing has to be 1. Because if you have 5 1 things in a row, I just said this goes to 31. We have 26 letters in the alphabet. Like, it's just not a letter, because for Baconian, you can't do mod math. So you would know that this has to be 0 if there's 5 of them in a row. Okay, so yeah, this is the reason why Baconian's a little bit confusing at first, because we've originally thought it to be 0 through 25 is A through Z, and we've just thought one letter goes to one number, that's it. Up to here, A through H, aka 0 through 7, that's true. But once you get to the value of 8, so A through H, you can actually have it go through I or J. And this isn't like probability, it's not math or anything, it's simply like which one makes more sense in the context. So for example, if I have 8, okay, so this, what you see right here, A's and B's, basically, A's mean zeros and B's mean ones. It's just a different way to think of it. Yeah, so 8, this is what 8 looks like. It can be I or J. It's completely your choice, just depending on the situation and what makes sense. Why? That's a good question. I don't know. They just like wanted to make stuff weird. Sadly, we have to follow. Yeah. But if these are the letters that follow, if you have ACK in the box, it's not going to be I ACK in the box, right? It's going to be Jack in the box. So you kind of have to read the context and then choose the correct letter. So basically what I mean is that you want to solve the letters around the ambiguous values. So the ambiguous values are 8 and what is that? 19. Yeah, so the ambiguous values are 8 and 19. So if you ever encounter them, you kind of want to solve the 5-letter groups around it first in order to get better context. You can make the assumption that all 8s are I because I is just a lot more common than J. You can also do the same kind of with U, but it becomes dangerous if you do it too much. Like obviously you could just go back and read through your quote and see if you made a mistake too, which is generally what I do. I might have to take a screenshot of this chart just so we have an easier time of doing it later. But one thing you'll notice too, when you merge 2 letters into the same number, these are both 8, that messes up all of the letters after it. So in my head, K is 10 because in every other math cipher, K is 10. But here, K is 9 because we didn't go, oops. We didn't go 8, 9, 10 like we usually do. We went 8, 8, 9. So every letter that's in between K and T, it actually has 1 subtracted from its value that you'd think is normal. So for instance, one of the anchors is K is 19, right? In regular math ciphers, T is 19 in regular math ciphers. T is actually 18 here. And you can see that 16 plus 2 is 18. And like I said before, the reason is that you merged 2 of these letters into 1 mapping. So everything else is going to be shifted left by 1. And it becomes even worse after you do it here because everything's merged into 19 here. But that means for W through Z, you already merged 2 different letter pairings. So actually, why is it merged? Yeah, good question. There's no real reason. They just wanted to make our lives hard. Yeah, so W is usually 22, right? In affine and visionary, in most math ciphers, it's 22. But here it's 20 because we had this one merger, we had another merger. So we essentially had to shift it to the left 2 times. Yeah, it's just I and J and U and V. When you're taking like an actual test, it's actually given on like a reference sheet. All of these are given on a reference sheet too, but it's just good to have it somewhat down to memory because like it becomes actually a really slow process if you're only relying on the reference sheet. But yeah, definitely you need to rely on it somewhat. Okay, so before we practiced converting to base 10, now we need to do convert to base 10 and then convert that to another letter. So here, this is what I just described. Wait, hold on. Result. All right. I would communicate these as -1 and -2 actually, because you know what? It's fine. It's fine. So basically, I'll just assign these again. And then if you want to tell me the number you get first, and then if you're a little confused on the letter converting part, I'll actually just do one here. So remember 2 to the 4th, 2 to the 3rd, 2 to the 2nd, 2 to the 1st, 2 to the 0th. these are false. We don't care about them. So we have 2 to the 4th plus 2 to the 2nd plus 2 to the 0th. 16, 4, 1. So we get 21. And we remember that 21 is usually V, right? But if we think about it, IJ and UV are merged. So actually, this is 8, and then this is at 19. Because we have to think about 1 less than what U would be. U is usually 20. So 21 is actually 2 after V. So UVWX. So this is actually X. No, you're good. There's actually a lot of ways you can avoid doing the math once you like have a certain background in Baconian. Like this one, I know it's X just because it alternates. Like I know if ones surround the zeros, it's X. That's the way I think about it in my head. The last one is supposed to be A, but then it becomes C. Hold on, I have something covering the last one. It becomes C. Oh, the reason that one doesn't shift too is because, yeah, like Irene said, the IJ combination and the UV combination only affect the letters that come after it in the alphabet. Because if you think about it, if I just go A, B, C, D, yeah, it's just A. Like A, B, C, D, E, F, G, H, all the way up to there were no mergers. It's just 0 through 7, A through H, like normal. But once you hit I and J are the same 8, then everything after that is shifted -1, like to the left 1. And then once you hit UV equals 19, then everything after that is shifted -2. Yeah, it's a little bit hard. Okay, so I'll just assign these again. Okay, I can't see down there, so I'm just gonna go up here. All right, I think that's everyone. Oh yeah, nice catch, I or J. Oh wait, yeah, I mixed up you guys, my bad. That one is I or J. I wasn't reading last names. Yeah, yours is E. Nice job. E does not have 4 things. That's my bad. L? Yeah. The reason I know L and X is because they're kind of like reverses of each other. So in X, the ones surround the zeros, but in L, the zeros surround the ones. There's a lot of ones you can just memorize based on like visuals. Yeah, so you got 23. The way you can think about it is you just convert it to a letter first in your head. So Z is 25, so if you go Z, Y, X, it's usually X, right? But X comes after I and J, and it also comes after U and V. So you'd start from X, and then you'd actually go forward 2 letters. I guess I realize why I put plus here. Like when I say plus, you go forward that many letters. So if it says result +1, you go forward 1 letter, or you go forward 2 letters. Hold on, N, let me see. 8 plus 4 plus 2, 12, 14. Hold on. Yeah, see, even I'm having trouble doing this. So it's O, but then everything got shifted back. I think Julie, I think you subtracted instead of adding. That's my bad. Yeah. Yeah, I had the thing messed up here. I think, so like you get 14 from these numbers, right? And that converts to O regularly. I think you have to add one and go to P instead of -1 and go to N. Wait, 13? 8 plus 4 plus 2. Oh, yeah, that's all right. Your sister, yeah, your sister would know. Yeah, so I think it is P. It's fine, it's fine. We all do it. I think I missed somebody's in the chat, so I'm going to scroll up. Yeah, so yours is Z, Sierra. Sorry I missed that the first time. R. Oh, yeah, it looks like R because this is 16 plus 1 is 17, right? But the reason it's not R is because R comes after I and J in the alphabet. So instead of R, you have to go one letter forward to S. And the reason we're not adding 2 letters is because R still comes before U in the regular alphabet. Oh, no, this is not a word. We're just converting random letters. Yeah. Okay, so I'll just go through and do some. 4 plus 1 is 5, so F. And the reason we don't do anything weird to that is because A through H is normal. This is 8 plus 2 plus 1, so that's 11. And that's usually L, but because this comes between IJ and UV, we're adding 1 to it. So it's 12, which is M. Here we have 4, 2, 1, yeah, H. That's the last normal letter. All right. Yep, that's A. 16, 2, so that's 18 regularly. If we think about what that converts to, it's S. But that's in between IJ and UV, so we have to add 1. So it's actually 19, which is T, yeah. Here we already said that was Z, P. Okay, yeah, we've done all of these. Nice. So these were kind of out of context, right? They were just random 5-letter blocks that are like all over the place. But now we're going to actually like do something with them. And that's like where the Baconian cipher comes in. I think there's an answer key on the next slide. Yeah, I think we got them all. All right. So this is what I showed at the very beginning of class. Remember how I said if there's 5 things in a row, then that thing has to equal 0 and not 1? Because like you can't have 1, 1, 1, 1, 1 because that equals 31 and that's not a letter because we're not doing modular arithmetic in this case. It has to be 0, 0, 0, 0, 0. Look for something that repeats at least 5 times here in a row. Yeah, so V is 0. So this is the very annoying part where you fill everything in. But technically, you know there's only zeros and ones, and there's only A's and V's in here, so you can just automatically say that A is 1. Let me see how much time we have, whether we can do this entire thing. Yeah, probably. Oh, and the slightly annoying thing is that a lot of test writers, you would think that they put the blocks of 5 so that they match up with the end of each row, so you can just keep going. but a lot of the times they will have like your block of 5. I'm just going to draw a line. This is kind of what we do to separate blocks of 5s. You will have a block of 5 like this. So you have 3 in one row and 2 in the next. So you just have to be like extra careful that you divide your blocks correctly. I don't know that that's necessarily how this one divides, so I'll erase that for now. And we can just do the first line for now. 1, 2, 3, 4, 5. Yeah, I guess you're right, Irene, but it's just like generally that case won't happen, right? Because 0, 0, 0, 0, 1 is B, and then before that you had an R. RB is like possible if you talk about like carbohydrates or something, but it generally like doesn't happen. It's a safe guess, right? It's still a guess, but it's a safe guess. And if you like start doing the beginning of the cipher and it makes absolutely no sense, like you have P, J, K, A, W, like this makes no sense, then you would just know that your guess was wrong and then you change your guess. Okay, while I'm dividing these, if anybody wants to like convert to either numbers or letters, and then we can write them down, or if you only convert to numbers, then we can do them together. T. Yeah, I think that is T. The way you can count is, I know that this thing is R, like where it's just 1 by itself. So you can like count by ones after that. TH, yeah. A lot of quotes start with TH. Yeah, it is the, because the next one is E. Actually, it might be like there or something. Yeah, all those V's together is A. I'm just not there yet. Yeah, lots of A's. A is a very common letter. Okay, yeah, this is what I was talking about. We have VA, VA here. That's a series of 4 letters. So we actually need to take 1 letter from the next row and add it on to make it 5. So it's slightly annoying to look at, but it's what we have to do. Okay, so the next one is 0, 1, 0, 1, 0. This is L. Like I was saying before, if you have zeros surrounding your ones, it's L. That I just like, at some point the math is not worth doing because it takes kind of long, right? So if you can come up with a visual shortcuts, like 1 surrounding zeros is X, then it's really helpful. Oh yeah, the reason it's confusing, Julie, is that when we do the shift thing and then we add 1, we're basically like converting. Okay, so like this is S if you think about it's 18, but S, like it falls in between I and J and it falls in between U and V. So you're right that you add 1 and you go to 19. But when you convert 19 back to a letter, you're converting it with the regular system. You're not converting it with the messed up system where I and J are together and U and V are together. Yeah. Yeah, no problem. Yeah, so this is E again. This is S. Yeah, you're right. I think this is another S because it's just the exact same 5 letters. Yeah, the less. Oh wait, this is 0. Yeah, so this thing here, 0, 1, 0, like I'm talking about this thing. That's another L because it's just the 0 surrounding the 1s again. Zero, 1, 1, 0, 1. So this would be 8 plus 4 plus 1. So that would be 13. And that falls, well, that would be N, but it falls in between IJ and UV. So you would add 1 and you would go to O. So 13 plus 1 is 14, and then you convert the regular way back to O. Yeah, generally, like I was talking about, you want to develop some like visual sense. Like this one is, I know is N because it's 12, like 8 plus 4 is 12. And then you add 1 and it's 13, and then it's N. But I just know it's N because you have those like 2 1s in the second and third places, and everything else is 0. Oh, I think it's actually the lesson. So this is I, and then this is another S. So the lesson is L. Just for like actually knowing what the quote is, let's continue. All right, we said this was A. So you only use the messed up system. How do I think of it? I guess you never actually have to use the messed up system. It's a way to think about it, really. It's not really how you want to be converting. So what you do, you add up the numbers. This is 18. I'm just going to use this example again. 18 is S. And then the only time you use the messed up system is to see whether that letter comes in between IJ and UV, after UV, or just before IJ. So here in this case, S comes before UV, but still after IJ. So you add 1, and that's 19. And then you convert back regularly to T. You never actually convert with the weird system. The only time you use the weird system is to see whether a letter falls in between the two merged places before either of them or after both of them. You never actually convert using that. Like I would never say that 18 goes to T. I would always say that 18 goes to S, and then from there I would add 1. Here, I'll do another example. So here we have 16. Oh wait, no, those are all zeros. So actually we would only have 8, which is I. Here we have 1s where the A's are. So this is 4 and this is 1. So that adds up to 5, which is F. Okay, these weren't that helpful because you don't have to actually shift anything. All right, this one, you have to shift something. So you have a 1, this is 0, 1, 1, 0, 0. You have a 1 in the 8th place, and you have a 1 in the 4th place. I'm just saying 8 and 4 instead of 2 to the 3rd and 2 squared now. So that adds up to 12. What you do in your head, you convert to M. And M is in between IJ and UV. So because it's in between the two merged places, you just add 1. So 12 plus 1 is 13. And then you convert using the regular method back to N. So you never convert with the messed up system. You always convert with the regular system. And the messed up system is just a way of thinking about, do I have to add 1 or do I have to add 2 or do I have to not do anything? All right. I actually think we're going to move on just because I want to show that Baconian, we've actually been doing a slightly simplified version. So there's not always going to be 2 distinct letters. This one is like, it's obviously time consuming because Baconian is just time consuming as a cipher itself, but it's easy, right? Because we can almost automatically see what 0 and 1 are. But if we go to here, there's different ways that people like to do stuff. You can see like the entire alphabet is here, right? One way that people like to do it or people as in like test writers. This is a half-half example, aka 0 through 13, A through N, map to 0 or 1. And the rest of the letters in the alphabet, O through Z, map to 0 or 1. If that's a little hard to wrap your head around, here, V is in between O and Z. So it's worth, well, we don't know that it's worth 1, but we can kind of assume that it's either worth 0 or 1. So if this was the opposite, it would still make a letter, but like it wouldn't work as well. Because what happens a lot is that your quote starts with the. So if you guess something and then you get a T at the start, go with your guess, because your guess is probably right. Okay, I'm not going to demonstrate those actually, but just assuming that the beginning of the alphabet is 0 and the latter half of the alphabet is 1. Just tell me what numbers I should put in this 5-letter group. Here, actually, I'll just do it this way since it might be a little bit harder to do it all by itself. Is C in the first half or the second half of the alphabet? First, yeah. So we covered that the first half of the alphabet here, we're going to call 0. What about K? Actually, what about K, F, and J? Yeah. The next 4 are 0, 0, 0, 1. The reason P is 1 is because it's in the second half of the alphabet. So here we see that everything is false except this 1 in the 2 to the 0th place. So 2 to the 0th equals 1 equals B. So this is B. Yeah, so basically you just keep going on. And generally, it's really annoying. Test writers don't tell you how the Baconian is mapped. So if you see letters like this, barring any like really annoying stuff, it's either going to be split half and half, odd and even. Odd and even as in like Z is considered odd because Z maps to 25, which is an odd number, while like U is even because U maps to 20, which is an even number. That's what I mean by odd and even. They could do vowels and consonants. And all of these, I'm talking about like how they will split 0 and 1. There's some very weird stuff that they could do, but these are generally like the top 3. Yeah, they won't tell you. It's when you see a Baconian on a test and it has letters, generally you just go, you test the first couple letters, you go half and half, you go vowel consonant, you go even odd. If it doesn't work, you just move on. It's not worth your time. Have I done it before? Yeah, it happens on like every test. Well, generally when you're doing Codebusters, partners specialize in like different stuff. So I don't do these anymore because got my partner to do them, which is great. But I did them a lot in like my freshman year. How did it go? I mean, you usually get them because they're not made to be hard. They're just made for you to be creative and eventually get them. So it does take some time. Like this Baconian cipher, it would probably take like 10 minutes if you're like up to speed. But like it's worth it in the end because usually you do Baconians after you're like finished with the rest of the test. Okay, yeah, this is what I was talking about. So it can be split, if you have letters, it can be split even, odd, prime, composite. You don't really see this that much, but I guess it could happen. So prime numbers are like 2, 3, 5, 7, 11, 13, 17, 23. Those are the ones you would use because that's just like the scope of the alphabet. So like these could all map to 0 or 1, and the other stuff would go to 0 or 1. I'm trying kind of hard to like not blow your mind here. Let's say they say the quote, they tell you as a hint that the quote is by like Ben Franklin. Then if you try everything else and it doesn't work, it might be that the letters B, E, and N go to 0 and everything else goes to 1. It could be something like that. When there's symbols, it's generally easier because the symbols have relationships with each other. One that you will see a lot is exclamation point at hashtag, I guess that's a pound sign, $, percent, caret, and I can't draw this. That's not an 8. That's like the ampersand. It's what you get when you hit shift 7, asterisk, and then these 2 parentheses. What this is, generally what this is, it's shifted numbers on your keyboard, right? So if you take a look at your keyboard, shift 1 is exclamation point. Shift 2 is at, and so on. So it can either be that this is 1 through 5 shifted. It can either be that these are 0 and the 6 through 0 shifted are 1, or it can be the other way around. Or you can have 1, 3, 5, 7, 9, the odd numbers. Oops. You can have these shifted, which would be like, I kind of have to look, versus the other shifted symbols that map to either 0 or 1. I know it's like really confusing, but basically Baconian's a lot of trial and error. Yeah, so you basically just have to try combinations until one makes sense. You don't want to waste too much time, right? So you just do the first couple of letters until you get something that makes sense. Like here it says the first 2 letters can't be BB. If you try it out and you get like TH at the beginning, you're just set, you're right. Like that's the end, you're right. Keep going. All right, so this is the end of the slides, and we have a couple minutes left, so I guess we'll do more aristocrats again. It'll be a nice break from this hard cipher. I think generally that this is the hardest to get a hold of, because like patristocrats are hard because you don't have spaces and stuff like that, but this is definitely the hardest conceptually, and it just takes the most time. All right, let's just do some group solves of these. All right, you know how it works. Just yell it out if you see anything. Oh, for this one, remember that a letter can't map to itself. So look at the 1-letter word, and there's pretty much only one choice that it could be. Yeah, it has to be A, because I is already in there, and you can't map I to I. What could this contraction be? Generally, if there's 3 letters before the apostrophe, it can only be one thing. Or like the 3 letters can only be one thing. Yeah, it's either your or you've. Okay, I think it's you've, because you'll see, like, if I put this here, I think this word is until. And like, I don't know how to explain it. You've is you have, right? So it's you have, and then the next word has to be in the past tense, which means it probably ends in ed. So I think this is D and this is V, which if you can get this word, it definitely makes more sense. I'm just going to say it is D. Oh, you've probably, yeah, I can see what this code is. You can, You've heard it said in a different way. Yeah, it's never. 7 actually happens sometimes, and it's really like disorienting when you get it. Oh, I'll just fill in until. But never is definitely more common. Like I would say like 10,000 times more common. So yeah, just assume that it's never. When you see that kind of word pattern. Where should we go? I guess here. Yeah. Okay, so here it says a mile. So this is about, this is a verb, and it's about like some kind of transportation because you're going across a mile. So what could this verb be? Verb be? I guess transportation is kind of a not good word to describe it. It's like a form of travel because you have to do something to go a mile. You know what? Actually, let's do something else because these are both one letter things, so they don't help us with the rest. Can we get this word? We talked about a man. The subject of our sentence is a man. So what could this be? Yeah, his. Have you guys heard this word before? I feel like some of you might have. It's kind of an old word for shoes. Yeah, moccasins. Yeah, criticize. And we're back to this word. So never criticize a man until, yeah, I saw, until you've a mile in his moccasins. So it's like, don't judge until you a mile in his shoes. What do you do in shoes? Yeah, you walked. Oops. Uh, we've got a common word pattern here. Oh, you can probably guess what this word is too. Box is there twice. It's pretty common. Yeah, this is the. Is box and. It's not and. It's slightly, it's not a very, oh yeah, it does start with in the end. That's a really nice guess. Yeah, box isn't and, but it's like a semi-common word. There's not many that have H in the middle of them, right? So just think about, yeah, those who. Those who is actually a 2-letter combination that appears a lot, especially at the beginning of quotes. Oh, we already used E actually, and you can see that this is not super common. There's a 4-letter word that begins with ON that actually happens quite a bit in aristocrats. Only, yeah, and that should help you get this word. People, yeah. Generally, people is one of the safest guesses to make if you see the word pattern. So just remember, if the first and the 4th letter match up, and the 2nd and the 6th letter match up, it's probably people. What could this be? Try, yeah. R. Fail, yeah, nice. I guess we can do one more. Okay, so you have this 1-letter word here. The reason I'd be careful before saying I, yeah, I think it's A, is because if you think about it, like, if you put I there, there kind of has to be a vowel after, right? Because you can only have like, I did something, I action. But here, this does not seem like a verb. It's like some kind of weird word. So I think it's A. All right, what is this word? Generally, if you have a letter, oh yeah, I'm asking about the letter, not the word. So it's either E or O. You can narrow it down to that because it's probably a vowel and you have it in the middle of, like you have two of them repeating in the middle of a four-letter word. If I look here, I know whether it's E or O. If I look at this two-letter word, yeah, it's O because E doesn't start two-letter words in English. This is pretty common. What could this be? It could be so, but S isn't as common as something else I'm thinking of. Yeah, two. What could this be? Two. Yeah, the other two. What about this? Worth. What word usually follows worth? Like if I say a day's worth, yeah, of. This is an hour, yeah. Your food. Can we see the second word? It might be a little bit easier to see right now. What if I put this in? Is this easier? Oh yeah, I guess I'll put in dollars, sure. Yeah, babysitter. Teenager. Make sure you read the context. Fine is definitely more, yeah, five. Fine is definitely more common than five in quotes, but it's talking about something dollars, so that's why you'd say five. So a babysitter is a teenager who gets $2 an hour to eat $5 with your food. All right. That's it for today. Like always, I'll assign, okay, wait, yeah, somebody asked last class for this. I'm pretty sure we're all in it, but I'll just show the code. That's it, if you need it. 66 LAP4. Yeah, so like always, I'll upload the recording, the slides, and the Baconian homework. For some of the Baconian homework, I'll tell you what the letter mapping is just because like it's really hard to do it at first without that. But there will definitely be some unhinted ones on there. All right, so that's the end. See you guys next week.
Bye. Thanks.
Yep.